Hey everyone, quick note before we begin this episode. There's a lot of current events going on in the United States right now, and there's one thing I'd like to talk about that is space related. NASA's budget proposal is coming through Congress, and it's bad, folks. It's really bad. It would cripple NASA's capabilities and cripple the United States as the premier space science center in the world. If you live in the United States, contact your congressperson to vote no on this budget to save NASA, basically. Without a budget, without adequate funding, NASA, our space program, can't do cool little missions like the one we're going to talk about today. So it is paramount that we maintain these capabilities. Also, I do think that Jared Isaacman would not be a good NASA administrator, so if you agree with that sentiment, also voice that concern. On today's episode, Mercury, up close and personal. First you saw it with Bigfoot walks on Mariner 10, but now we're going into orbit. On today's episode of End of Mission, I'm Paul, the pressure-fed, really hot astronaut, because Mercury's really hot.
I'm Face of Sarcasm, and I took you to Mercury the first time.
And
we're going back.
And we got lost and spun out of control.
Yep.
Your tape recorder failed.
We lost the tape recorder.
Yep. The gremlins got it.
Mm-hmm.
So we're going back to Mercury on Messenger. And again, for those of you listening, if I still have audio issues, I'm still trying to fix them. It's just,
get a better microphone. Get a better microphone.
I'm going to get a better microphone off the internet. I can't ask
any microphone.
Okay, let's go dig one up out of the garbage. There we go.
I thought you were gonna say dig one up out of the ground. You plant in the microphone seeds, they grow, and then you harvest them.
Yeah, little podcast seeds.
Yeah.
Okay, so I don't have any other custodial notes on this. No. All right, so this is Messenger.
To Mercury 2, the sequel.
Yep. So, as we last saw, Mercury is an interesting place, but getting there is kind of hard. It's interesting, but hard to get to.
So you gotta take a detour to Venus first. You gotta swing around.
Yeah, gotta take a left at Albuquerque, that kind of thing.
Yeah. Yep. Fine. Go to turn left at the place, at the corner with a guy at the pitchfork. He tells you scary stuff. And you keep going.
Yeah, and of course your star tracker gets lost because something shiny got on the way.
Ooh, shiny, jingling keys.
Here we go. So this leaves a lot of questions, right? Mariner 10 looked at Mercury in 1974, 1975. It showed us.
Kind of just glanced at it.
Yeah, took some pictures and ran away, and then exploded apparently, to the point where we just don't know anything about Mercury. As much.
We kind of know some things. It's big, it's gray, it's got craters everywhere.
But as you can see from this picture, this is a mosaic of the map created by Mariner 10, and you'll notice this is not dust. This is just no pictures.
This is not a potato that's been slightly peeled.
That's true. So there's a lot left to be desired about Mercury.
Mariner 10 only saw less than one half of Mercury.
And it's this way up until the 2000s. In fact, just to age myself, back in, I think, second or third grade, with his Scholastic Book Fairs, I got this book, A Rough Guide to the Universe by John Scalzi. He's a science fiction author. Mm-hmm. And it's got, pictures and maps of, Venus, Mercury, the stars. And in it, as I'm showing you now, is this picture.
This exact picture,
This exact picture. I got this book in, 2004?
Yeah.
That sounds about right. Because we just didn't know anything about Mercury. The problem is getting to Mercury is pretty hard.
Yeah. It took a miracle last time.
Yeah. So the first inklings of a return to Mercury actually happened in about 1983 under what's called the Planetary Observer Program. The idea was to build interplanet missions out of commercial satellite buses. Okay. Instead of dedicated science buses, you just here's a commercial satellite bus, we'll put some science instruments on it. Because if you think about it, geostationary orbit is basically deep space. They operate for a few years, a long enough time to accomplish some of these missions, right?
That is true. So basically, instead of building it all yourself, DIYing it, you instead just go to the hardware store, because geostationary orbit's basically deep space. Okay.
Yeah, because I think Europa Clipper is based off of the Space Systems Laurel 1300 bus.
And that's geostationary?
It's a geostationary satellite bus.
And now we're just chucking it to Europa because there's something in them water. There's water in them hills.
Yeah. Now, the Planetary Observer program really didn't do anything. The only time it did happen was Mars Observer, which flew in 1992 and then exploded.
But hey, that's what got us Mars Global Surveyor,
That's
which
true.
we have an episode on,
Yes.
my first episode.
Yes. We're covering Mars Observer later this year.
Yay.
The problem with getting to Mercury is delta V requirements. You want to put anything in orbit of Mercury to, planetarily observe it, you need a heavy lift vehicle. Well, that's expensive,
Yeah.
right? Because you need a bigger satellite, you need a bigger spacecraft, which means bigger launch vehicle. It's not in the budget.
Yeah.
No.
Which is actively still being cut at this point, right?
Yeah. Oh, yeah. And then, so interest in Mercury is revived in 1998
What happens in 1998?
because of a paper published by JPL. Chen Wan Yan said you could do gravity assists.
Again! Hey, just like
Who knew?
the first.
Yeah.
Just like Mariner 10.
So the idea, because the problem is you want to do a Discovery class mission. That's what we're talking about now at this point. Discovery class, right? What's it? We just did a Discovery class mission.
Is that the 2001 A Space Odyssey?
2001,
That big one?
2001 Mars. No, that's different. That's different. We're talking about Mars Odyssey. I think is Discovery class. The problem is you want to go to Mercury. You have to do it on flagship. If you do heavy lift direct orbit of Mercury, it's a flagship class budget for a Discovery class mission, which you just don't want to do, especially if it doesn't work. But you could launch a Discovery class payload into orbit of Mercury with multiple flybys to slow you down.
Right, so instead of just doing the one Venus flyby with Mariner 10 to do a flyby at Mercury, you're instead doing multiple of these to get into orbit.
You're doing 6 flybys.
Jeez.
So you're doing it. So you launch from Earth, you do a flyby of Earth, you do a flyby of Venus, flyby of Venus, flyby of Mercury, Mercury, orbit. But you can do it.
Yeah,
And such,
you can.
Mercury surface, space environment, geochemistry, and ranging was selected as the 7th Discovery class mission in 2000, alongside Deep Impact.
So what? Okay, out of curiosity, what are the different class of missions?
We have Explorer class. These are smaller missions. These usually go into low Earth, into orbiting the Earth. ISEE-3 is an Explorer class mission. It's basically scaling of budget. So flagship class missions are like Cassini, Galileo, the Mars rovers.
The big ones.
The big ones. These cost about $2 billion, right? But
Jeez.
you're doing a lot of spectacular science with these. They're also kind of high risk. Like the next big one is Dragonfly, the Titan helicopter.
Oh, well, okay.
Yeah. Very expensive, but high science return.
Doing awesome stuff with it.
Yeah. Discovery class missions are kind of in between.
Okay.
So they'll go to Mercury, orbit it, and take pictures, but they're not going to land on it or anything like that.
Got it. Okay.
Right. I think we said this before. We will do an episode just explaining the constellation of what exploration class missions are.
Okay.
There's also like the New Frontiers program, which New Horizons is part of. There's a few stratifications. We'll talk about those at some point. We'll make it a special for later this year, I think.
Okay.
But Messenger is the 7th Discovery class mission. Woohoo!
Yeah.
So what is, and that's an acronym because it's NASA.
Of course.
So this is our spacecraft. It's a cute little guy.
Yeah.
So it weighs 1.1 metric tons, about 2,400 pounds. It's got about 1,300 pounds of propellant on it because it's still got to go into orbit of Mercury.
So that's a lot of propellant. So most, like half of it.
Yeah, it's a lot of propellant. You still got some stringent delta V requirements.
Yeah.
Its main propulsion, which is on here, you look at better on this side, is a Lyros 1B. That's a geostationary satellite apogee motor because it can do long duration burns into orbits.
Got
Kinda
it.
like-
Okay. And this is just off the shelf basically.
Pretty much, yeah. It's commercial off-the-shelf type programs. Again, don't reinvent the wheel. Buy one used.
Yeah.
So on board, some interesting technological developments here. You have solar arrays that have optical solar reflectors on them because you're going near the sun, so you don't need as big as solar arrays, but you also want to make sure you don't like absorb all that light. You want to reflect that. The sunshade itself, which is we're seeing the backside of here, is made of a large ceramic cloth.
Ceramic cloth.
Ceramics are really good for heat resistance.
Right, but how do you get ceramic cloth?
You just weave them.
Because I think of ceramics, I'm thinking of just like pots and pans.
Instead, it's like fibers of these ceramics.
Okay.
They're like woven together.
That's weird.
Yeah.
It's NASA.
It's NASA. They can do this kind of stuff.
Yeah.
So you just take a look at our spacecraft for a quick second. You can see also the antenna on it's pretty interesting because it's right here on this, and it's right here. They didn't want to do like a steerable antenna, like a high gain, like a dish, because you'd have to maneuver the spacecraft to point at Earth. Whereas this one's adapted from military spacecraft, and it's a bit more adaptable to communications. So you don't actually have to directly like point at Earth. It becomes a challenge when you're orbiting really close to the sun.
Right, because then you're constantly the spacecraft's orientation is constantly changing, so you have to like reorient the dish all the time.
Yeah. So instead,
this one's you swiped it off the military. Yeah. And
you went to one of the air shows.
Broadcast.
Yeah, you went to an air show and just kind of walked away with one. Just act like you belong. Just take it. Thanks, guys.
Just bring a screwdriver and a wrench. Should be good.
Wear a safety vest. People will let you in anywhere.
Yeah.
So there's 6 goals of this mission.
Okay.
Characterize the chemical composition of Mercury's surface.
Sniff what kind of glue it's making.
Yep.
Okay.
Study the geologic history of Mercury.
What do the rocks do over time?
Yeah, what do the rocks do for fun? 9 to 5, commute.
Yeah, what do they do in their off time, on the weekends? Do they get together, barbecue?
Yeah. Study the nature of the global magnetic field.
Why is it the way it is?
How is it the way it is?
Because it has one. We know from Mariner 10 it has one.
It does have one. We got some measurements of it.
Yeah, but why? Why is it the way it is?
Determine the size and state of the core.
It's a great movie.
Great, yeah.
Highly recommend.
Yes. Determine volatile inventory at the poles. Because
gonna go in there and check the warehouses.
Yep. Some guy again. Hard hat, safety vest. You can go in anywhere.
Get a clipboard and you can write everything down.
Study the nature of the exosphere. It's got an atmosphere. What is it? How is it? Why is it? What's it made of?
Yeah,
it's a good place to
go.
Had
to cancel a couple because Mariner 10 had to cancel a couple of the UV spectrometer
because it melted. No, it froze. Something broke on it.
It broke. The door broke.
So let's see. Of things we should pay attention to. Hey, look, there's star trackers.
Is that one gonna get lost too?
No.
Good.
And we have a helium tank for the pressurization of the propulsion system.
And the birthday parties.
That's kind of important. So we have 9 experiments on board.
Okay.
Let's take a look at them.
Yes.
So, Mercury dual imaging system. It's
not just the single. They got both.
Got both of them. 2-for-1 deal kind of thing. So
is that basically just the wide versus the narrow field of view?
Yes. It's looking at Mercury up close with a camera.
So basically just like Mariner 10.
Yeah. So we have the gamma ray and neutron spectrometer. That's this guy.
Ooh, cool. So is that brass or gold?
I think it's brass.
Oh, still looks shiny.
Yeah, it is pretty shiny. So it's measuring gamma rays emitted from the surface when they're hit by cosmic rays. So Mercury's hit by cosmic rays. It's gonna throw gamma rays back. And it's gonna measure those because you can use those to determine the composition of the surface.
Oh, interesting.
Hydrogen, magnesium, silicon, oxygen, iron, titanium, sodium, calcium, and if you really are excited, potassium, thorium, and uranium.
Nice. So bananas and nuclear bomb stuff.
Yes.
Sweet.
And the neutron spectrometer also does basically the same thing.
But just with neutrons instead of the gamma rays.
Yeah. So we have down here, this is the X-ray spectrometer, maps elements in the top millimeter of the crust based on X-rays from the sun hitting the surface and then bouncing off.
So basically just counting the dust on the surface.
Yes, that's pretty much what it's doing. And
the top millimeter of crust.
Yes.
So the loose soil.
Yeah. And then we have the magnetometer.
Wonder what that does.
That's a good one. Good question. We don't know, man. We just put it on.
It's not like Mercury has a magnetic field or anything.
So then here is the Mercury
Ice cream maker machine.
or bullhorn. Like the Blues Brothers when they're driving around, they have the
Yeah.
it's like that.
Yeah. It's the air horn. Yeah,
Yeah.
You honk this.
That's you startle the Mercury dust up. Here you go. Wake up. Here we go. So this is the Mercury laser altimeter.
Ooh.
So
because it's measuring the surface.
Yeah,
right?
as far as infrared laser at the surface, it'll bounce back, and you're measuring the travel time because that's the altitude.
Yes.
So it's also going to measure the libration, which is the wobble of Mercury, if it wobbles at all.
Okay. And because it does wobble, right? Because it has minor axial tilt.
It's like 2 degrees, I think.
Yeah, it's really tiny, but it has that axial tilt, and then it's also an elliptical orbit.
Yeah.
So it probably does librate
a little bit, and it's got an accuracy of about a foot.
Oh yeah. Just like the Mars.
It's
orbital laser altimeter.
It's almost like these are very similar components. Common things.
Interesting.
Kooky.
Weird.
So we have Mercury atmospheric and surface composition spectrometer. That is this one.
Masks.
Yep, masks. So it's an ultraviolet infrared spectrograph that measures atmospheric gases and radar reflective materials near the poles. It's also looking at iron and titanium bearing silicates like pyroxene, olivine, rock.
Okay, so it's looking for rocks.
It's looking at rocks. What are the rocks made of, right? Because that can
What
help.
do the rocks taste like?
Yes. How do they feel? What do they look like in this room versus this room?
Corner. We gotta check the lighting.
That's true. And we'll do some radio science.
Fun.
Oh, I missed one. Sorry. Then these two. Energetic particle and plasma spectrometers. So we have EPS and FIPS. Mm-hmm. These are measuring charged particles in and around Mercury's magnetosphere.
Right. So these are all a lot of the exact same experiments that were being done by Mariner 10, but just with much better equipment.
That works.
Yeah. And of course, Mariner 10 is just doing a flyby, whereas Messenger is getting into orbit.
It's going into orbit. It's going to be really cool, too. I got so many pictures. How many slides did you have on yours?
70-ish?
You had 63. I have 65. I checked.
Oh, okay.
I checked. I'm petty. So this is Messenger being built. So this is where they mount the antenna, right? So the sun shield goes on this.
Okay.
So you have a big propellant tank here.
Right.
There's all the science stuff. Here is the solar array being tested, as you can see. You can see the dark ones are the solar panels themselves. The shiny ones are the reflectors.
To make sure it doesn't absorb the heat.
Yeah.
Right.
Because again, you have to do some serious thermal management now. You're that close to the sun.
Yeah, because you're 3 times closer, because of the square root law, you're getting 10 times the heat from the sun. I like how they're going. Yeah, say ah.
Yeah. I know there's an asteroid that gets so close to the sun that its surface features are actually made by heat, like the heat of outgassing. That's a mission I'd like to see. That's a good mission to go.
Yes.
The problem is it's a really eccentric orbit that's really hard to get to, but that's an asteroid I'd like to see.
Yeah. What does that look like?
Yeah. What are the surface features determined by heat?
You watch. It's just going to be a bunch of pointy volcanoes and then lava flows.
Yeah, it's like crap. So here's the backside of the solar panels. You can see where they're all the wiring for them.
Yeah.
They can collect it together.
Very orange.
So here's the spacecraft being assembled here. You can see the solar arrays are folded up. Here's the magnetometer, of course, right here. Oh, of course, it's the same color,
as everything else.
You see there's the propulsion system there.
Yep.
So here it is. Again, they're putting stuff on. Mm-hmm. This is a guy on a Segway, I guess.
Look at me.
Yep.
We know, James. Put it down. Come on. We got to finish wiring up the battery system.
Yeah. Gonna make sure the gyroscopes work this time.
Got to put in the tape recorder.
God. Here it is being fueled up.
I like that they're in spacesuits for that.
It's hydrazine.
Oh. Okay.
Liquid cancer.
The best flavor.
Yep. So this is actually the Wikipedia page for hydrazine, I think.
Oh,
it's the Wikipedia page for spacecraft propellant is this one, because here's these guys in spacesuits putting it in. This is safe. Don't worry.
Okay. I like that it does have mixture, big, bold.
Well, yeah, it's safety.
Black and yellow.
It's safety requirements. You have to.
I also like that they are putting like that plastic cover over the solar panels. Obviously not to damage it, but also it kind of looks like it's about to be put in a cardboard box.
You're not that far off, actually. So here it is getting loaded on top of the Star 48.
Ah, yeah,
Right.
okay.
Again, it's Discovery. What do you think the launch vehicle for this mission is?
Is it a Delta II?
Wow. That's wow.
Prophetic, I know.
So here's one of the mission guys talking about it.
Oh, yeah, and there's the camera.
Yep, there it is in the background. Then here it is being ready to be loaded onto the Delta II. See? It's there. You're close.
Yeah, yeah. Wrapped in a cardboard box. This side up, handled with care.
So this is the payload fairing for the mission. They're doing inspections of it.
Oh, he's painting the inside black.
Yeah. So here it is being loaded on top of the Delta II at the launch pad, LC-17, which I think the Air Force Missile Museum is right like there, which we've been to.
Oh, okay.
Yeah, it's right around there. So here
It's in Florida.
Yeah, it's in Florida. There's a lot of things in Florida though.
Yeah.
So here it is, of course, on top of the Delta II. They're putting the payload fairings on in the launch site. Here's the Delta II. Wow. Let's see if there's anything else exciting about Delta. I like Delta II. It's one of my favorite rockets. I'm sorry. Look at it.
Yeah. It's blue.
It is. That is. You can see they have 3 airlet engines on it. You can see.
Yeah, because they have the bigger nozzles.
Yep. That's a different logo than the one I'm using. For the launch.
Yeah. What happened to that one?
Couldn't find anything on it. Because the one on the rocket, the correct one, is the one I've been using. I don't know.
Maybe it's like, imperial versus metric.
Yeah. All right, so the launch is August 3rd, 2004. At
A date which will live in infamy?
no.
Okay,
At 2:15 in the morning.
Oh, gosh.
Well, you gotta launch at night. You gotta close to the sun, right? You gotta catch up on it. Sneak
Oh,
up.
yeah. You approach the sun by night.
Yeah.
I forgot.
It's launching from LC-17B on a Delta II.
Wow.
Let's see. This is the launch.
Nice.
Good. Again, Delta II is a good looking rocket, especially to see launch.
Good shots.
Yeah.
Those are great shots.
I like the big smoke just kind of around it. It's great.
Yeah.
So 57 minutes later, Messenger is on course for an Earth flyby next year. The spacecraft at that point has a velocity of 10.7 kilometers a second, a little over 6.5 miles per second.
This booking it.
So to put this into perspective, from our house to the high school is 7 miles.
So it'd be covering that in just over a second.
A little, yeah. That would have been so much more useful when I was doing driver's ed, don't you think?
Yes.
'Cause I biked there.
Just that fast.
Yeah. So this is our flight plan then. So
Right.
August 2nd, 2005, Earth flyby 1. Then in October 2006, Venus flyby. Then June 5th, 2007, another Venus flyby. First Mercury flyby is in January 2008. The second one's October. And then the third one is in September 2009 with orbit insertion in March 2011.
Gosh, so it just takes forever to get there.
It's better than it costs less than a direct flight. You go
So what you're saving in money, you're making up for in time.
Yes. It's like all those connecting flights you take to go places, right?
Yeah.
And this time you're taking like regional airport to regional airport on Cessnas. My God.
Yeah. Versus, well, hey, at least you're saving yourself like $1,000 on having to buy a plane.
Yeah, it
ticket.
only takes you 2 weeks to get there, but you know.
Yeah.
I've actually seen a few of those to go around the world. It's like 4 days to get there.
Gosh.
Oh man.
Yeah, I would not want to be on this. This is some real Kerbal stuff, you know?
I have done stuff like this in Kerbal. So let's gear up for our first Earth flyby. So this is a picture that Messenger took of Earth and the Moon.
Oh, nice, cute.
Really cute. So the closest approach to Earth was about 2,400 kilometers over Mongolia during its flyby.
So that's pretty close.
Yeah, but this is South America, as you can see,
Yeah.
right? 'Cause there's the Andes right there.
Yep. There's the Andes, and there's like the tropical zone stuff.
Yeah, the international. I used to know what this was. I took a biogeography course.
ITCZ, something like
Yeah,
that. ICTC.
Yeah, that's Earth. Got a few pictures of it.
It's looking very gray.
Well, you feel that way sometimes, okay? So we do our first
Right.
Venus flyby of about 3,000 kilometers. I couldn't find many pictures of this part. So here's Venus.
It's kind of pale. You can see why, all the Earth-based observations of it before Mariner 10 was all just, it looks like it's a pale dot.
Yep. Wow, that's exciting.
Yeah.
So we'll do another Venus flyby. This one's a bit closer, 340
Yes.
kilometers, right? And it did some work in conjunction with Venus Express, the European Venus orbiter, which died a couple of years ago.
Oh.
So this is the image that was taken on the left. And on the right is enhanced, where you can see the chevrons of Venus's atmosphere, of its super rotation.
Yeah. Oh, that's some good stuff.
Oh yeah, very exciting. So
I will say though that this does look lower quality than the one that Mariner 10 was taking.
yeah,
How close was it?
340 kilometers.
I mean, that's pretty
That was
close.
pretty close. The primary goal was to go to, Mercury.
Yeah, but you're at Venus.
We already mapped.
stopping
We
by
we
twice.
mapped Venus with Magellan later this year. But
So?
you notice how I haven't talked about anything breaking yet?
I mean, yeah, that's fair.
Oh yeah, that's important, isn't it?
Yeah, but it's all like after 30 years, yes, none of the stuff breaks, but the camera quality is still bad.
You sure about that? Because what's next?
Mercury.
Mercury.
Hey, we're back.
So this on the left is a picture of Mercury taken by Mariner 10.
Yep, that's stitched together mosaic.
It's stitched together. It's also in my book here. You can see it. That's not it, but it's in my book. This on the right is what Messenger sees.
I mean, looks pretty similar.
Looks pretty similar. But you'll notice that it doesn't need a mosaic.
True.
It's a lot nicer looking. And this gets in about 200 kilometers. Doesn't yours get that close?
Yeah, so if I remember correctly, somewhere around there.
Yeah.
A few hundred kilometers.
Yeah.
Mm-hmm.
So this is the way out.
Okay.
So
that's
you'll notice you've never seen this before.
Yeah. Because right in the middle, because there's the Colores Basin. We only saw like the right half of it.
Yeah.
Yeah, we only saw the right half of it with Mariner 10. That's all we could ever see because it kept showing up at the same time of day.
Yeah. Now we're
So
seeing
this
it
entire middle section is new.
This is
unexplored terrain.
all new.
All new, baby.
One flyby.
Yeah. Also, it's colored.
Yes, it is colorful now. We invented
What
color since then.
We
got color
Since
TV.
1973.
Yeah, we invented air conditioning and color TV. So then we do the second flyby. Another 200-kilometer flyby. You can see, again, you're getting some up-close views, and you're seeing a lot more of Mercury.
Of the planet.
Yes.
Yeah.
Because you're also counting at
see,
different times.
Yeah, it's not the exact same time every time. But yeah, you can see like these
Yes.
bright vertical rays
Yeah,
going down.
the stripes, the rays, you have impact craters. I think that's Kuiper.
Really?
I think that's Kuiper, yeah.
I thought it was more northern, slightly more northern.
I think it's upside down.
Oh,
That
okay.
makes sense, yeah. Yeah, again, I can't remember orientations on some of these. Don't worry, for the other images that are up close and better, I labeled them. I know what they are.
Okay, good. Good.
Yeah, it's this crater.
Duh. You know this one,
Yeah,
right?
Yeah. So Messenger's seeing a lot.
Yes. It's getting up close, a lot more
So
personal.
this is the third flyby.
Okay, that looks a lot like the moon.
Yeah. Shocking, isn't it?
Yeah.
So you see this crater here. I think this is Vivaldi.
Okay.
Don't worry, it's labeled on another image. So that's a
All right.
Vivaldi crater. You can see though, it's a double crater feature.
Yeah, because you have the little one in the middle and then the bigger one on the outside.
Yeah. You can see like the different impacts. This is Mercury up close.
Yeah.
Isn't this nice?
Yeah.
When everything
this is
works.
nice. Yeah. Mm-hmm.
Yep.
Uh-huh. Yes.
Don't worry. When we do the Mars rovers, I'll take the one that got stuck and died.
Spoilers.
Yeah. But, we did three flybys. End of mission. There we go. Right. Oh wait, no, we're going into orbit. So.
Oh, okay.
March 18th, 2011, or the 17th if you're in the United States.
So the 17th of March,
Yes.
2011.
At like 8:45 p.m.
Mm-hmm.
Messenger does a 15-minute burn of 900 meters a second and enters orbit.
That is a hefty burn.
Yes.
I mean, Mariner 10 only had like 120 meters a second.
Yeah. You saw what happened to it.
Yeah.
The confirmation that it's in orbit comes on 15 minutes later.
About 25
25 minutes later, yeah. On the 17th of March.
Mm-hmm.
So it's in an orbit of 15,000 by 200 kilometers. So about 9,300 by 120 miles at 80 degrees. So it's a nice polar orbit.
Mm-hmm. Mm-hmm.
And you can see it's very elliptical.
Yes.
This is good for a few reasons. One, it's a lot easier to get into an elliptical orbit than it is into a circular one from interplanetary
Right.
velocities.
Yes.
It's also good for thermal management. Because, so remember, Mercury's hot,
Mm-hmm.
which means it's going to dump the heat up
And that's where your spacecraft is.
into Messenger. This allows it to cool down and, as it goes away from Mercury.
Okay.
And it's also kind of like Galileo, where this is, right, it do a lot of observations up close and then dump all the data on the coast apogee.
Right.
Now, Messenger is going to be slated for 1 year-long mission.
Okay. I mean, he spent like 7 years getting there, and it's going to be there for one.
It lasts a lot longer than that, of course, because it's good.
Yeah.
The other benefit to being in orbit for this long is... I'm asking you. Think about why Mariner 10 only saw certain parts of Mercury.
Well, that's because it was doing it was seeing it at the exact same spot at the exact same time.
Yes.
So now you can start to see what it does when over the course of Mercury's orbit, and get to see the entire part of the planet.
You can see all of it. For a year is, 365 days. How long's Mercury's orbit?
88 days.
That's like, what, 4 Mercury years?
Yeah.
Which means, and like 2 Mercury days or whatever. Right?
Yeah.
So you can see all of it throughout the course of the mission.
Yeah.
So the normal mission, 2011 to 2012. They extend it another year, and they extend it after that. I'll tell you. We'll get to the end of mission later.
Okay.
Let's talk about some science. Why we're really here.
Science.
So Mercury has an atmosphere and magnetosphere. We saw this on Mariner 10. Yeah, you thought we were talking about surface features. No, magnetic field. There we go.
Yes.
Yes. So Mercury has a tenuous atmosphere.
Okay.
Specifically, we're talking like a sodium tail on this thing.
Sodium. Why sodium?
I think it's like getting blasted off by the sun.
Okay.
I think it's caught and then blasted off by the sun.
Okay.
It
Interesting.
also has magnesium and calcium in its tail as well. But here's...
Oh, so all the stuff that a growing boy needs.
Yeah, it's a good healthy cereal. Go get it.
Yeah.
That's why Messenger did so well. It got to eat a good healthy meal every orbit.
Mariner 10 just went, huh?
Yeah,
couldn't
couldn't get its breakfast. Had to go, right? At the beginning of all those shows, right, they have the big breakfast. It's like, oh, here's a toast. I'm out.
Yeah, it bites one bite of the toast, one sip of the orange juice, and gone.
Gets lost breaks.
Yeah.
So the coolest part about the sodium tail is if you're standing in the correct spot on Mercury at Mercury night and it's really active, the atmosphere would have a faint orange glow.
So you could see it.
Yeah, very tenuously though. A faint orange glow though.
It kind of almost like seeing a city, like the light from a city in the clouds at night.
Yeah, like that.
Oh, cool. That'd be awesome.
Very faint, but you could see it from the surface under the right conditions.
That'd be dope.
So you can see more. It's got a calcium magnesium tail. I think magnesium was the spectacular one because I didn't really think it'd have a magnesium tail.
Mm.
That was pretty interesting. Yeah.
Yeah.
The atmosphere is seasonal.
I mean, seasons are like 5 days on Mercury.
Yeah. You also
Just
remember
booking it around the sun.
It's an elliptical orbit. It's got
Yeah.
seasonal. Yeah. So it's got a magnetosphere. That's not it. Again, here's stuff coming off, right? You can see like the shape of the tail, where it's coming from.
Yeah, it's kind of got like a B shape to the tail.
Yeah. So here's the magnetosphere. So I don't know much about magnetic fields. I'm not an electrical engineer because I'm normal dad.
Yeah, take that.
Yeah. So the magnetosphere of Mercury is very dynamic because it's small and it's close to the sun. Sun has a lot of influence on it for obvious reasons.
Really?
So the dynamic evolution of the magnetosphere is about 100 times as fast as on Earth.
Ah, okay.
Yes. The magnetosphere is also offset from the poles by like 20% of like a radius.
So it's angled?
Yeah, it's offset from the poles.
Okay.
Yeah.
That's interesting. Why is it offset? Why it do that?
Good question. I don't know. We also saw, I read this, I don't understand it, is the magnetic field flows along Birkeland currents, which means the field flows through low conductivity layers near the surface of the planet between dawn and dusk.
I don't know.
I don't know what that means either. I'm not a planetary scientist.
Low conductivity layers near the surface between dawn and dusk. I am so confused.
I don't know. I'm an engineer, not a planetary scientist.
Okay, yeah.
Let's get to some more fun stuff.
Pictures?
Let's get some pictures. No, let's talk about volatiles. I'm sorry. Yeah, rocks. That's the fun stuff.
Yes, finally, the thing we want to talk
So what
about.
you'll see is Mercury is a lot like terrestrial planets. You can see based on
Really?
So we got Earth. This is Earth, right? Earth's a little
Earth's mantle, Earth's basalts.
right. Mars is the pink triangles there. You can see the moon's up here, and moon's weird. It's got a lot of
Moon's doing moon things.
moon. Yeah, weird.
Where do they call it lunar soil instead of lunar regolith?
Heathens. I will send a strongly worded email to these people.
Good, you better.
And I'll end it with grow crystal count dust.
Yes.
I also see in terms, again, it still has a similar composition to terrestrial bodies, right? So this is Mars, which matches the same color as my pen. Messenger, Mercury is down here with the terrestrial oceanic crust, so you can see. Weird, Mars meteorites are similar in composition. Oh yeah, because it's terrestrial. And the moon is...
It's all terrestrial.
Yeah, and the moon...
And then the moon's doing its own thing.
Just over here. There we go.
Venus, strangely enough, is like way up and over as well. It's kind of like it's branching off of that curve.
Yeah, it is weird.
From Mars.
Also, we have limited data, I think, on Venus.
Yeah, Venus lander, GRS. Yeah, there's like, what, 3 of
There's
those?
a few of them. Yeah, they lasted for an hour.
Yeah, before they melted.
I think we're going.
And then the moon's just doing it off its own
The
thing.
moon's just there. He's just happy to be here.
Yeah.
I think we're doing pictures next. There we go.
Are we?
Yes.
Okay, good.
So here is the same spot imaged on the left by Mariner 10. And here's what it looks like when Messenger sees it.
So big changes happen.
But if you look closely, though, you can see, right? There's the double crater walls.
Yeah, because there's the one circle over on the right, and you see the smaller one and the bigger one down on the right. But all right, you see the fresh, bright one up on the top right.
Yep, that's this guy.
Yeah. So you could, you can see it. You can map it out.
You can see the value of seeing parts of the planet in different light conditions. And it also the shadow helps you kind of gauge heights of things too.
Yeah,
right? You can see. Look, you can see, like, this geologic feature here. This bulge here. I think it's called a rill. I think they're called
something like that.
I have one of the next slides actually has one of these on it, so that's how I know.
Okay.
But you can see this crater here, right?
Yeah,
right. It's about here. You can't really see it in the Mariner 10 pictures.
So wait, these features were here when Mariner 10 took them?
Yes, these are the exact same features, different lighting conditions.
Ah, okay.
Value of that.
Yeah, that's a significant value.
Yeah, because you can see.
You actually kind of see what's going on.
You can see it.
So this is also why, like, for professional photography, this is why you don't, like, ever take the pictures. This is why, like, the 90s, you saw, like, with snapshot cameras, why the lighting was always gross, and you always had, like, sharp, tiny shadows behind it. It's because the light and the camera were at basically the same spot, with slightly offset. But that's why with professional cameras and why you're taking professional images, the lights are coming from the side.
Yeah.
Right? It helps to define the features of the face.
It also helps define features up close and personal shots.
Yes.
So the yellow circle is the Caloris Basin based off Mariner 10.
Uh-huh.
The blue one's the actual Caloris Basin. It's actually a lot bigger.
Slightly bigger, yeah.
So this is again Caloris Basin. Here it is. All big and caloris-y, basin-y.
It's very, very heat.
So one of the most interesting discoveries from Messenger is here in this picture.
What is that sublimation?
Possibly. Those are called hollows. A bunch of craters just have these weird bright features that look like speckled like holes.
That's weird. It does look like the sublimation I showed you with Mars Global Surveyor.
Yeah. It's probably that, but we don't know. We still don't know.
Weird.
We gotta go back.
Dang.
We gotta go back.
What?
We gotta go back.
We gotta go back.
Oh,
yeah.
wait. Don't worry. Just wait. But yeah, so these were discovered on Mercury. They're called hollows. We didn't see them on Mariner because, outgassing and stuff. Maybe it saw these, got distracted by them.
Yeah.
Right. But yeah, so we found hollows on Mercury. In the craters.
That's fascinating.
Yes.
Inside the craters, the bottom of the craters?
Yeah, this is the bottom of the craters. You can see there's the crater mountain here, but they're inside the craters.
I'm hard. I still, my brain's still struggling to identify.
So this is the crater wall rim, and you go down into it. This is the crater bottom. So
okay.
It kind of goes like that.
Okay, so these are all at the bottom of that crater.
Yes, and then you have a little crater peak like here.
Okay.
This is the crater mountain.
Got it. And the light's coming from the left.
Yeah, but this is one of the big discoveries from Messenger.
Okay, I see. Okay, now I see. Now I see better.
Yeah.
Yeah, it kind of looks like the crumbling, like when plaster or paint comes off of concrete, decaying concrete walls. Yeah.
It's like that. It's cool.
That's fascinating.
So we got some altimetry, of course. So here's a crater. You can see features. Here's another crater. Hey, there's a crater.
Big crater there.
Oh.
Who knew?
And you can see there's other shallower craters in some of these. Right, you can kind of see on this.
Yeah.
And you got here, crater peak, up, and down there. So you got some you got a big topographic map of Mercury.
Yeah, I mean that's the whole reason why you're mapping this thing and getting it a polar orbit.
It's kind of important to understand what the planets look like on the surface. Weird.
Yeah, interesting.
Kooky. So this feature here is called Duccio Crater.
Okay.
It's this guy. Oh, also all the craters are named for artists.
Yeah, except for
Kuiper.
because
He's an artist of science.
He's an artist of science, was on the team, and unfortunately passed away before Mariner 10 reached Mercury.
Yeah. So you can see Carnegie rupees here. That's this feature. It's like the kind of the big mound. That is caused by tectonic activity from the planet shrinking.
Oh, sweet!
Yeah, it's crustal shrinking. That's what makes that.
Awesome.
There's also evidence of volcanic activity.
Yes, volcanoes. Let's go.
So you can see here. So this is called Angkor Vallis, right? Ignoring this crater here, this right here, all this violent features most likely caused by fast-flowing lava on the surface.
Oh,
from
rivers of lava.
Yes, that solidified, of course, because it's
it's Mercury.
Yeah. So there is evidence of volcanism. You actually see more of it here. So this is Timgad Vallis. This is a lava plain.
Yeah, look at that, because it's pretty smooth.
It's pretty smooth, and it looks like flow.
Yeah, kind of like river. It has that dendritic appearance.
There's like 5 or 6 of these sites all over Mercury that we found and looked at.
Wow.
And this is Timgad Vallis. It's named for a lost Roman town in northern Algeria. That's how they got their names, like forgotten cities. Yeah.
That's awesome.
Yeah, it's volcanic.
Yeah.
So also see scarps and graben. So this right here, pointed to by the arrows, is a scarp. It's a little uplift feature, a couple dozen meters tall.
Okay.
Made by geologic activity, tectonic potentially. And
doesn't the moon kind of have something similar to that?
Yeah. These are still probably active.
Oh, okay.
Yeah. So you see, Mercury is probably still active.
That's
a planet.
okay. That's a new revelation.
Yeah. Now, active in the sense is, on geologic scales, but it's still a dynamic planet.
Things are still happening there.
So we're also looking at the poles.
Yes.
We're specifically, since, Mercury has basically no axial tilt, what would that mean for a crater up near the North or South Pole?
It never looks at the sun. It's always in darkness.
Or you could have a peak of eternal sunlight.
Ooh.
Like that.
Yeah. Okay, so it's always lit by the sun.
Yes, no matter what, most likely.
That probably gets really hot.
Yeah, but it's good for solar power and suntans.
Yeah.
You could put a sauna or a spa up there. You get sunburn like that. We get third-degree sunburn.
Yeah, you want to go onto this cliff and die?
Because when I was in the Philippines, I got second-degree sunburn on my feet.
Cool.
Yeah, I didn't know you could get second-degree sunburn until I got it. But of course, so we're looking for craters of eternal darkness.
Yeah, because the water can freeze in there.
Yes. And, again, since Mercury has this, and you can see it for a full year, you can guess and find them.
Ooh.
So this is Tolkien crater. I think it's Tolkien. The guy who wrote Lord of the Rings, which how do you spell Tolkien?
I think
it's how it's spelled. One of these is like Porphyrokiv. They're labeled in the next slide. But you can see we have craters of eternal darkness on.
There's just no sunlight going down into them.
No sunshine.
Awesome.
But isn't that cool, though? Look at that. Look at these, and you can see these features. And they're also looking inside craters. Actually, NASA figured out how to do that. To kind of guess what the interior structures of some of these craters were based off of minimal sunlight.
Oh, okay.
That's really cool.
I mean, you also have the laser altimeter.
That's true. That helps. So, we have our neutron spectrometer, right?
Okay, so it's IEN for Tolkien.
That's true. So in this little one here, it's kind of hard to read. So if you're looking at neutrons coming off the surface, right, because you're looking for neutrons over the craters. If it's flat, there's no ice. If it curves, there's ice.
There's ice.
So let's look at the neutron curves here.
Well, it curves.
Curves.
There's ice.
So these yellow spots here on the map are ice.
So there's ice on the moon. Or not the moon. Mercury.
Same way we found it on the
also
moon. Yeah, same way we found it.
Yeah.
There is water ice on Mercury.
That's awesome.
There's our day spa right there.
Right there. Look at that. You get a cold ice bath and then, get 7,000 degree burns.
Incinerated.
Yeah.
All right, I'm done.
Yeah.
So, guys, again, all these artists, of course, you got Chesterton, Tolkien, Kandinsky, Prokofiev. I think he's a composer. Yoshikawa, Gaudi, Iganu, Kyuying, Petronius.
Chesterton.
God, I'm not saying that.
And then try again.
Yeah. Oops. You can see there's different features. I got Mendelssohn. There's like the famous one in the southern hemisphere is Beethoven crater. Yep. I told you Vivaldi, he did the Four Seasons.
Yep.
But there is water ice on Mercury.
There's water ice in them poles.
Isn't that cool?
That is awesome.
One of the hottest places in the solar system has cold.
Yep, has a lot of cold.
Stieglitz. But yeah, so if we ever want to, I don't know why we ever want to explore people on Mercury, but you know where to go now.
Yeah. Go to the poles.
After 7 years in your spacecraft.
Yeah. You get to see, you launch from Earth, then you go back to Earth, and then you go to Venus, and then you go to Venus again, and then you go to Mercury, then you go to Mercury, then you go to Mercury.
Are we there yet?
Yeah. Still got 6.5 more years. Dang it.
I forgot my toothbrush.
Well, you don't need a toothbrush where you're going.
Nope. Straight to the peak.
Be incinerated on the peak of eternal sun.
Straight up there, buddy. So this is an enhanced color map of Mercury. What do you think this feature is?
If I had to guess, yeah, it's chlorophyll, obviously.
So whenever you see pictures like these, the reason they're made is not because they're pretty, but because they can enhance like surface features, right? You're enhancing the colors to see. Again, there's the Caloris Basin.
Yeah, you can very clearly see it.
You can also see different like mineral compositions of the surface, right? You can see there's different like the northern hemisphere of Mercury has lots of volcanic basins and like floodplains,
Yeah. Yeah.
which I think we got on the next slide. No, we don't.
Dang it.
So I picked this one because you're flying overhead. You can figure out the topography of the surface. So this is what the topography, and it's exaggerated a bit, like 10 times tall as it is.
Right. It's that way you can like see the separation.
Yeah, but the crater we're looking at here is actually Lovecraft and Roerich. So Nicholas Roerich was a German Volga artist who painted really great landscapes of like I think the Himalayas, which inspired At the Mountains of Madness by H.P. Lovecraft. Roerich is named directly in At the Mountains of Madness, or one of some of Lovecraft's stories, because he liked his art so much. So it's kind of nice that these two craters are next to each other. I thought that was nice.
Yeah, that's cute.
Yeah. So then, there we go. So this is Rembrandt crater. So this the big crater here is Rembrandt, and you can see it's flooded in with like flood basalt.
Yeah.
But you can see other craters, and you can see kind of like blemishes and like rills and all the different surface features within these craters, as they're shaping the the geography and geology of Mercury.
Yeah.
And here's another volcanic flow here.
Oh, you see a delta with that
That's
one.
a volcanic delta. You can see like flooded in craters. It's all kind of the same area, but you can see the different features of Mercury. You have plains.
A lot of these different lava flows, this volcanic activity, the craters all impacting and whatnot.
It's like this place is still dynamic. It has a dynamic history. It's very pretty though. I mean, look at this.
Yeah, look at this.
And I think we're getting up to the pictures, just pictures now. No.
Okay.
So this is, Gamblegona Baloney crater. Actually, this the mountain here is named for that because it looks like this statue of Hermes, which was made by the artist that it's named after.
Sure, it looks like a croissant to me, but
yeah, well, you're not NASA now, are you?
I guess I'm not.
That's true. Then this one is named Waters. The dark spot there is actually ejecta from the impact that made the crater.
Oh.
Not volcanic outflow, but it looks like it, though, doesn't it?
It does look like it kind of vomited it up.
It's like, here we go. Okay, I'm done. It's named Waters for, like, a song, I think. Like Dry Waters or Muddy Waters, I think. Again, it's named for artists, musicians.
Right.
And this...
Okay, that's pretty cool.
And this is Mercury. These are some of the pictures I really liked of Mercury.
I like the carpet bombing trails across the big crater.
Well, because as we know, asteroids, meteors are just crumbled rocks put together. So as it gets closer, they break apart from gravity forces and they split apart. And
yep, and then just machine gun the surface.
And this, of course, you see is a flooded-in crater.
Yep.
Here. And then you see some of the volcanic plains of the north. And these features also show up on Mars. They're volcanic plugs, I think.
Oh, okay.
Yeah. So, again, volcanism probably happened on Mercury.
You don't
like
say.
It did on Mars. We can tell.
Yeah.
And you can see like the different, like the waves of like frozen, solidified metal and surface features.
And rock, yeah.
And a really fresh crater right here.
Oh, yeah, that's bright and fresh.
That's a nice fresh crater there.
Oh, yeah.
Again, there's another flooded-in crater. You can see, right, the shapes there. The folds.
Yeah, sort of the Y shape of that one.
It
almost looks like a sponge.
Yeah. It's gorgeous, though.
Yeah.
It's
seeing even like multiple, the rings over on the right,
And hollows.
Yeah, those are hollows.
Those are the hollows. Yeah.
It's more hollows.
Again, a lot of craters have them. We don't know why they exist. They're most likely sublimation.
Right.
But don't know. We can't confirm.
Sublimation of what?
Exactly.
Do we know where those hollows are?
A lot of craters.
It's just all over the place?
They're all over Mercury.
Wow.
Yeah. Isn't that neat?
Interesting. Yeah. What's causing them?
Exactly. That's so interesting. So you can see like shadows and how they define surface features.
Mm-hmm.
Like the craters, the shapes.
You also see that like the terrain for the image on the left, the terrain on the right is much higher than the lower, smoother terrain on the left.
Yeah. You get a ridge. What makes that?
Yeah.
It's so nice and pretty.
And mountains, it looks like.
Yeah. Or craters.
No, that's a mound.
Oh, okay.
Cause,
That's true. Yeah.
Because it's bright on the one side and dark on the other, which is reversed from the craters, which go down. So it has to go up.
That's true. I wear glasses if you haven't figured it out yet.
Right.
So here's another crater, right, with these like scar features on the side. I think they're called fossae, I think. You just see the scarring. These are different features. They come from different, like the impact crater, of course, is an impact crater, but these are geologic in nature. I think they're from the compression of Mercury as it's like condensing and coming together. I think that's what causes these rays.
So this is just like this is basically tectonic activity.
This is like,
These are tectonic lines.
This is it's not it's stretch marks, right?
Yeah.
And it's just,
Gosh.
it's so interesting, and they're so huge too.
Yeah. These are giant.
Yeah, it's just giant geological features. We've only seen them once.
Yeah.
And you see on the right here, you can see another big floodplain of just volcanism and the melted terrain. And you get the cracks from all the different formations. And,
Yeah. And then seeing like the ripples and everything.
you can see like the rays too coming off.
Yeah.
It's just amazing. It's an amazing world.
Yeah. Just seeing all these different
It's
aspects.
cracked and craggy and
Looks like it hurts.
yeah. It's like there's geologic activity there,
Look, it's still geologically active.
Yeah. Weird.
Strange.
Again, I just found pictures I liked of Mercury at this point. It's like, look at these features. Look at this.
Look at these features.
Isn't this cool?
This is awesome.
Yeah. And you just, again, it's like, it looks like river beds, Like rivers supposed to cut those channels, but they're not.
It's so smooth compared to the rough terrain that you kind of see at there.
Oh, yeah, and this one too.
Yeah.
Probably a floodplain.
Yeah. Volcanic floodplain.
Yeah.
That's awesome.
It's just,
Rivers of rock.
there's Vivaldi again.
Okay.
Double crater feature. Of course, this is...
And then you can see it's smooth in the middle.
Yeah,
because it's filled
it
in.
melted.
Yeah.
And again, it's just like the violence you can see with like the shape over here around the crater and just the mounds and the shadows down over here. You can see just all these features.
It's incredible.
And then, of course, here's the southern hemisphere. I think this is Beethoven over here. This is Beethoven.
Okay. Oh, gee.
It's one of the biggest craters on Mercury. One of the biggest features.
Dang.
Yeah. I mean, the Caloris Basin is the biggest.
Yeah, that's the centerpiece.
Yeah, but there's also Beethoven. So there's actually water ice also in the South Pole.
Oh, well,
Yeah, there's more craters
so.
on the underside there too to hold it all. Look at this. It's this gorgeous world.
Yeah. Very gray, but I mean,
What are you talking
the
about?
features are incredible.
This is color. What are you talking about? And you can see like melted in craters too.
It's like these were once craters, but now they're melted over and
they're just covered in the next to another big crater here, of course. And you got and again, like these impact craters are all filled in and melted too.
oh yeah. Yeah, they're all filled in. Even the one on the right, you gotta see where the inner ring was.
Yeah. It's just it's a shame I'm not a geologist where I can't appreciate this fully.
Yeah.
Because these are fascinating features.
Just a gorgeous and incredible.
It's an amazing world.
Yeah. Just filled with lava, craters, and geological activity.
And at certain times of night, orange.
Yeah. Yeah. Oh my gosh, is that color?
Yeah. It's a little sign that says, come to this hollow.
Yeah.
And again, shadows give you a lot of features to look at.
Wow.
Right? You can see the rippling and the craters and the flows and the shape, like this one, like the topography.
Yeah, look at that.
Yeah, and it's just modeled with craters and impacts and the rippling. It's just, it's so cool.
That is beautiful. Holy crap.
Messenger got some good photos, I think.
Yeah, Mariner 10 pales in comparison
Yeah.
with these photos.
Oh.
These are
Oh
incredible.
yeah. Also, because this sec got a lot closer in, obviously. Because once they did the extended mission, they actually got closer in.
Oh, okay.
Yeah,
Yeah, that helps. You can see some
You can
details.
see like here too, like this feature,
Yeah.
like a canyon leads to a crater,
Yeah, it's just incredible.
and you can sort of see like, oh, this one's still gets sunlight, so there's some coming through like the topography, but it's just there it is. This is Mercury.
This is Mercury. This is a beautiful place.
More hollow. Again, it just looks like sublimation. It's got to be sublimation. Yeah. And you can see inside this crater here, so there's probably water ice in there. You're looking at it.
Because it's dark down in there?
Yeah, I think this is one of the craters with water in it.
Okay.
So if you look close, you get a straw out. There you go. Have a little drink. Cool yourself down. Fix your gyros, man.
Gosh.
But yeah, like these hollows, and because you can see the bright features, that's why were so interesting. Because it's like,
right,
what is this?
What's going on
and
here?
It does look like collapsed features or sublimation.
Yeah.
It's gorgeous.
That is incredible.
It's a gorgeous world. Also, in 2014, there was a lunar eclipse.
Oh.
This got a picture of it. So you can see, so there's the moon. That right,
There's the
you can see it
shadow.
right there. That's the shadow.
There's just a slight dark spot on on the Earth.
Yep. But I think this is one of the first ever lunar eclipses seen from another planet.
That's awesome.
Now, this is another shot and the last of my Mercury images.
Oh.
Yep. I did a lot. The problem is after a while they kind of do look the same. And Mercury is still a gorgeous and dynamic world, but these are the ones I picked the ones that I liked the most.
Yeah.
This is a good horizon shot where you can kind of just see like the mountains and the craters and the topography.
Yeah. It's kind of flat.
Yeah. But it's still like all the topography there. I mean, oh my god.
Yeah. There's still a ton of topography. You can see all the craters. You can see the bright spots. You can see the ripples in the mountains and all that.
Now, so in late 2014, Messenger ran out of propellant.
Kind of like Mariner 10.
Yes. But the helium tank still had enough helium in it that they could do some maneuvering. Right? Because if you think about it, it's a pressure-fed system. You're using helium to push the propellants out of the tanks into the engine.
Mm-hmm.
Well, you just push the helium into the propellant tank into the engine. Use that for maneuvering. So they keep it in orbit for a little bit longer. But
All right.
all good things must come to an end.
Mm-hmm.
On April 30th, 2015, at 3:26 p.m. Eastern Daylight Time, Messenger impacted Mercury at 18,000 miles an hour in Suisse Planitia near Janacek Crater up here.
Is it okay?
No. This is the last image it took.
Wow.
So I think it's safe to assume that Messenger is a resounding success.
Oh yeah. Oh yeah.
It's a resounding success. It returns 10 terabytes of scientific data.
Dang.
We saw the entire surface of Mercury. Every inch of it was mapped. 100%. We know what Mercury looks like. We saw volcanic activity. We saw the atmosphere, the magnetosphere. I couldn't find anything about the core, but we know the core is like this giant chunk of iron, like 2 feet down.
Yeah. It's like 85% of it is the core. It's a giant thing.
It's an enormous chunk of iron that's cooling and contracting, leaving these wonderful features, these impact craters. It's a world with history.
Yeah. Yeah.
And of course, because of this, we still want to go back, because what makes the hollows? What's going on? What's doing this? What's the surface actually like? The problem is Mercury is really hard to reach.
It's just too hard to get to. Yeah, you spend 7 years, flying from regional airport to regional airport on a tiny
Cessna just to get there. You can't afford a 747, but you can afford a Cessna.
Yep.
But that doesn't mean we're not going there. So,
because we still have Bepi Colombo.
Bepi Colombo is going there right now. It's on its way to Mercury. It's launched by ESA in October 2018. Back in December, it did its most recent Mercury flyby, which returned very nice images. It's going to arrive in November 2026. It was supposed to arrive December of this year, but the thrusters had a problem because it's a Mercury mission that broke. Now, unlike the last two missions, this is actually separate spacecraft.
Ooh.
This is the Mercury magnetospheric orbiter named MEO.
Okay.
This...
So that's just measuring the magnetosphere?
It'll be in a different orbit than the Mercury planetary orbiter. This guy.
Ooh, okay.
It's going to look at Mercury up close. Again, it's doing messenger, but newer. And this below it is the transfer bus. It's actually got its own separate propulsion system that's going to dump.
Oh, okay.
Yeah. MEO is going to go into more eccentric orbit than the planetary observer because it's a magnetic sphere, magnetosphere, right? It's different. You gotta go
it has different properties. It's like, what's going on with that thing?
Yep. It'll be there in November 2026. It does flybys like this one.
Ooh.
So this was Mercury back in September 2024.
Still as gray as I remember.
Look, you can see more ripples. Look.
Yeah.
There's ripples.
You can see more of it.
Yeah. Again, it's Mercury. It's this big, beautiful world.
Yeah.
And that's Vivaldi. That's how I know what that one is.
Yes.
This is Bepi Colombo.
This is Bepi
That's
Colombo.
Bepi Colombo. It's going to Mercury. Now, there was planned to put a lander on it. A little lander to land in the pole.
Yes.
That would have been really expensive because Bepi Colombo was planned like in 2008.
Oh.
Well, Messenger was en route, so you're not going to get that. Maybe next time. I know the Russians have talked about sending something to Mercury, but considering their last interplanetary mission slammed into the moon because of a programming error and current events, I doubt that's going to happen anytime soon.
Unfortunate. Very unfortunate.
But that is Messenger.
Beautiful.
Fun little mission.
Yeah.
I remember, because I followed not Mercury, I followed Messenger on Twitter. I followed it. I was there for the end of mission.
Wow.
Yeah. I was also there for the end of mission of Cassini as well, back in 2017.
Yeah,
so
yeah.
I follow them. I follow these missions on Twitter, so you can do that. That was Messenger. This
That's awesome.
is Mercury.
I like this shot in particular because it almost looks like it's like waves rolling up on the beach.
It kind of is, isn't it?
Yeah, because it looks like those are the waves, and then there's even like more like the foam of the waves and sea.
This is the sea, and then
it's like a rocky shore.
Yeah,
and it's like sand, almost like in the middle.
Yeah, sand.
Like the sand ripples.
It's being rippled and pulled by the waves as they come in and out.
Yeah.
Oh, is that a crater?
Maybe
it might be. We gotta find out. We gotta go there.
Gotta go back.
Gotta go back.
Gotta go back, Kate. Gotta go back.
Yeah. That's Messenger. That's Mercury.
That's Mercury. And that's the last American mission to Mercury.
Yep. We'll do one eventually when the budget arrives. Hopefully.
If ever.
Well, our priority should be, in my opinion, I'm more excited for a flagship mission to Uranus.
Gotta probe it.
Yes.
I'm on board with that. Yeah,
it's a Cassini Galileo style mission to Uranus would actually be very interesting because it's
maybe not Galileo because the tape recorder kept breaking. But...
Yeah, they have one VCR waiting. We're gonna do it. Come on, let's do this.
I got a great idea. It's brilliant. We're gonna use magnetic tapes.
This is wonderful.
Vinyl records.
But again, and actually, Uranus actually allows itself for a Galileo-style mission because the ratio of the mass of Uranus and the moons means it could do a lot of flyby to flyby type orbiting.
Yeah, that would be great.
The problem is it takes like 12 years to get there.
Yeah, it's hard to get to
unless you use
like Mercury.
Unless you use SLS. can use SLS to go to Mercury, too.
Yeah, let's use SLS. Come on.
Yeah, let's do that. We say, again. Hopefully that... Yeah. But yes, that was Messenger.
That was awesome.
That was a good mission. Good mission, a lot of features, a lot of science, sodium atmosphere.
Mm-hmm.
Again, you can go... Again, I linked the wiki archives with all, 1,000 images that it has of the surface of Mercury and all of its features. It's a gorgeous world if you like craters and lava flows.
And gray.
But, I mean, the ones with the shadows, I think, are the good ones, I think.
Oh, yeah. Those are the best ones.
Yeah. Hey, we've done a planet now. We've finished a planet.
We've finished a planet. That's all the missions that have gone to Mercury.
Yep, all 2 of them.
3 if we want to count Bepi Colombo.
Which we've covered it twice.
Yes.
Yeah, Venus has a handful. Mars has a lot more.
Yep.
We did Jupiter. Oh, wait, no, you're doing Pioneers at the end of the year.
Yep. And then we still have to do Voyager eventually when they finally die. It's been 50 years.
They should be dying pretty quickly, actually. I mean, they're pretty old.
Yeah. Most people don't live that long.
And I did, on our spreadsheet where we penciled in episodes, possibly in 2027, we'll do Voyagers for our 100th episode. We'll see. We'll get there. But that's Messenger. That's Mercury. Beautiful world. On the next episode, we're doing STS-94, 56 days after STS-83, which is the time it took to process that mission.
Yes, perfect. We're lining it up.
You can see how exciting this mission is.
It's got pizza.
And they liked it.
Yes. Pizza in space. We get the pizza party. Yeah. We're going back.
If I got off Mir, it's Pizza Hut.
Yeah. Got some Pepsi with it.
There we go. Okay. Any final thoughts on this episode? Messenger, Mercury.
Mercury's a gorgeous planet. We've only ever been there twice. The third time with Bepi Colombo. We can't do any more missions I can't do any more episodes on Mercury because it's the only times we've been there.
That's it.
So, great job, Mercury. You're a beautiful planet. We'll see you maybe in the future.
Yeah, of course we will. There's still more to learn. There's always more to learn.
Always more to learn.
All right. Do you want to end this?
Yep. So, thank you everyone for watching. Remember to grow crystal, count dust. This has been End of Mission.